Hi everyone, welcome to this lecture. So in the previous two lectures, we discussed the mathematics of support vector machine in detail, and we also derived one of the most important parameter for the support vector machine, which was the k. And we defined k is the number of units to cross the margin and reach the positive class. Furthermore, we also discussed how we can set the value of k in order to make support vector machine a soft classifier or a hard classifier. Also, we discussed how k can be used to regularize the support vector machine. Now, after discussing all this, it is very easy to understand the decision rule of a support vector machine or how support vector machine do classification about a particular data point. So here we can see that we have three boundaries here. This is a decision boundary, this is a positive hyperplane, and this is a negative hyperplane. So if we want to discuss the equation of all these hyperplane, let's see for the decision boundary. So for decision boundary, the equation is Wtx plus b is equals to 0. That is, if any of the point is on the decision boundary, it will not be classified as a positive or a negative points. So its distance from the decision boundary is 0. On the other hand, the equation for the positive hyperplane is Wtx plus b is equals to 1. 1 means that it belongs to the positive class and it has some distance from the, it belongs to the positive class and it has some distance from the decision boundary. And in the same way, the equation for this negative hyperplane will be Wtx plus b. Okay, and it will be equals to -1 for the negative class. Now, these are the three equations which help us in order to identify the point as a positive class or a negative class. So this is our decision rule now. If X is the feature matrix of a new data point, then this data point will be belongs to class 1. So this epsilon symbol called as belongs to. So Xi belongs to class 1 only if Wtx plus b either greater than 1 or is equals to 1. So if it is greater than or equal to 1, it means the data point with feature x will be either at here or will be far away in the positive class. So this is the condition or this is the decision rule for any data point to be classified as a positive class or a class 1. Similarly, if any data point wants to be classified as a negative class, that in that case, its equation should be less or equals to -1, or it should be present somewhere here in order to be classified as a negative class or -1 class. So this is the simple decision rule for a support vector machine in order to make classification about any data point. So here again, we can see that the k is an important parameter and it can control the amount of soft classification and hard classification. If we increase the value of k, in that case, support vector machine will become a hard classifier. And if we decrease the value of k, in that case, support vector machine will become a soft classifier. So those points, this point and this point, which are present at the positive hyperplane or at the negative hyperplane, are called the support vectors. So the support vectors set the distance from the decision boundary because they are present at the positive and negative hyperplane. So in this lecture, we learn about the decision rule of support vector machine. We learn that after understanding the mathematics of support vector machine and after understanding the importance of a variable k, it is very easy to understand the decision rule of a support vector machine. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.